Okay, let's get started. Now, you are on the last section, section 5 of chapter 12. And just to wrap it up, this is our last Zoom session. The next time I'll see you on Zoom is next Friday, just in case you guys want to say goodbye to everybody. But you've all done your work, you've all done the quizzes and the tests, so everybody will be finished on May 15th. Nobody has to stay 2 weeks after that to do anything. Okay, so what we're doing here is called using recursive rules with sequences. Recursive rule. What we have been using is called an explicit rule. It gives a sub n as a function of n, where n refers to the number of terms you're dealing with. So these explicit rules is a sub n equals 3n plus 1. It's simply a function of n. A sub n equals 2 to the n minus 1. That's an exponential function of n. Those are explicit functions of n. What we're doing today is going to be called a recursive function of n, where the a sub n is, it can be a function of n, but what's more important is that it's a function of preceding terms, which we would call a sub n minus 1. So your formulas are going to look like a sub n equals something in terms of a sub n minus 1. So in other words, a recursive rule gives first of all, gives the beginning term. It has to tell us what a sub 1 is. And then it gives a recursive equation which tells how a sub n is related to preceding term, which would be a sub n minus 1. Now there's actually two type of recursion rules we're going to do. There's the ones where they give you a sub 1, and then your a sub n is a function of a sub n minus 1. And then they get a little fancy, and they give you a sub 1 and a sub 2. And then they give you a sub n as a function of a sub n minus 1 and a sub n minus 2. You're given two terms, and you have to find your formula in terms of the two preceding terms. Those are the two things we're looking at. So again, with sequences, there's two types of problems. One where you're given the term generator, you're given the recursion rule, and you have to generate the sequence. Those are the easy ones. And then there's the type where you're given the sequence and you have to find the recursion rule. You have to come up with the a sub n. Okay, now, first thing we're going to do here, write the first 6 terms of the following recursion rules. So this time I'm giving you the a sub n rule and you're writing the sequence. And so a sub 1 is 2 and a sub n is a sub n minus 1 plus 4. So that's where a sub n is the sub n minus 1. And so the first term is 2. So we start with 2. And then the next term would be a sub 2 you're letting n equal 2. And so a sub 2 is going to equal a sub 2 minus 1, which is a sub 1 plus 4. So your a sub 2 is a sub 1 plus 4. So it's 2 plus 4, 6. The next term would be a sub 3. And a sub 3 is going to be a sub 3 minus 1, a sub 2 plus 4. So the next term is the preceding term plus 4. You get 10. A sub 4 is a sub 3 plus 4. 10 plus 4, 14. What type of sequence are we generating here? What is that?
Arithmetic.
What special sequence is that? 2, 6, 10, 14. What's the next number?
Arithmetic.
It's arithmetic. So arithmetic ones are going to be easy to work with. Here you're given the term generator and you generated the sequence. With an arithmetic one, if you're given the sequence, it's going to be easy to find the term generator. It's just the previous term plus your D. And that's what we're going to talk about right here. An arithmetic sequence gives your a sub n as a sub n minus 1 plus D. You get your next term from your previous term plus D. So if it's an arithmetic sequence, it's easy to find the term generator. The other one it's easy for is a geometric one. Let's look at this sequence. A sub 1 is 4, and a sub n is 3 times a sub n minus 1. So I'm giving you the term generator, and you're going to generate the sequence. So what's the first term of this sequence? It's 4, isn't it? What's the second term? A sub 2. It's 3 times a sub 1. So it's 3 times 4, 12. And a sub 3 is going to be 3 times a sub 2, 36. And so on and so forth. So there you're given the term generator, you're generating the sequence. And again, what's going to be easy is when you're given the sequence and you have to find the term generator. In a geometric sequence, you're going to get a sub n equals r times a sub n minus 1. So for those two special ones, it's easy to do. It's easy to generate them, and it's easy to get a sequence and come up with the term generator recursively. It's the general ones that can be a little tougher, and you'll see as we go on. So first thing we're going to do here is play find the rule for these two sequences. What is the term generator for this sequence? First, look at it and tell me what type of sequence it is. What is that?
Arithmetic.
It's arithmetic with common difference what?
10.
10. And so now we want to write the term generator. So when you write a recursion formula, you start with saying what a sub 1 is. So a sub 1 is 3. Then you say what a sub n is. And it's going to be what? A sub n minus 1 plus what?
10.
Plus 10. So given the sequence, here's the term generator recursively. So you can see it's not an explicit rule. It's not a function of n, it's a function of a sub n minus 1, preceding term. And now look at this sequence. What type of sequence is this one? Anybody?
Geometric.
It's geometric with what ratio? What's R?
2.
2. And so first of all, a sub 1 is 16. And then a sub n equals what? R2 times your a sub n minus 1. Okay? So here we've covered the two types of problems you're going to get. Given the term generator, generate the sequence. Given the sequence, generate the term generator. Come up with the rule. All right, now those were for arithmetic and geometric ones. Now we'll get into some different types. Here we're going to be given the rule and we're going to write the sequence. So this should be pretty straightforward. You're given the rule. You just need to write the sequence you get. Now look at this rule. It's a sub n equals a sub n minus 1 plus n. So it's kind of a combination. It's somewhat a function of n, but it's also a function of a sub n minus 1. So it is a recursive rule. It's not an explicit rule. And so write the sequence. So what do we start with? What's your first term? 2, right? Now, what's the second term? Well, that would be a sub 2, which is a sub what? A sub 1 plus what?
2.
We let n equal 2 here. So it's a sub 1 plus 2. And what is a sub 1? So a sub 1 plus 2 is what? 4. That's the next term. Now let's look at a sub 3. You want to find a sub 3. It's going to be a sub 3 minus 1. A sub 2 plus what? Plus 3. So the next term's the previous term plus 3. So you get 7. A sub 4 is going to be a sub 3 plus 4. So now you're adding 4 to 7 and getting 11. Then you're going to be adding 5 to 11 and getting 16. You're going to be adding 6 to 16 and getting 22, and so on and so forth. So here you're given the term generator. It's a recursion rule, and here's the sequence you generate. Now think about it in reverse. If you were given this sequence, do you think you would discover this rule? You see where that's a little tougher to do, to try to figure out this rule from this sequence. It's easy for arithmetic and geometric ones. We can figure out the rule. But for these other ones, it can be challenging. Okay, next one here. A sub 1 is 2. A sub n is n times a sub n minus 1. So the first term is 2. Your second term, a sub 2, is 2 times your first term. So 2 times 2, 4. Your third term, a sub 3, is 3 times your second term. 3 times 4, 12. Your fourth term is 4 times your third term, 48. Fifth term is 5 times the fourth term. 5 times that, 0, carry the 4, 240. So on and so forth. Is this making sense? Are you seeing this?
Yes.
Okay? You're just plugging the n in and doing what the rule tells you to do. And here the rule involves n together with a sub n minus 1. So again, consider being given this sequence. Do you think from this sequence you would discover this rule? That's going to be tough to do. Okay, next one. Now, this one, I wish the book wouldn't do this. But there are some problems in the book where they start with a sub 0. Why? I have no idea. Because it is your first term is a sub 0 now, which means it should be being called a sub 1, but they call it a sub 0. But your a sub 0 is your first term, 4. And now for n, then you want n equals 1. If this is a sub 0, you need to find a sub 1. So a sub 1 is 1/2 of a sub 0. So 1/2 of a sub 0 is 2. Like that. And then the next one would be a sub 2 is 1/2 of a sub 1. So it's 1/2 of a sub 1, which is 2. And so it's 1. In fact, you can see what you've got here is a geometric sequence with ratio 1/2. It's just starting with a sub 0 instead of a sub 1. I wish they wouldn't do that. It just screws everybody up. But sometimes they start with a sub 0. But you would just keep getting 1/2 of the previous term in this sequence. Okay, now here is another type of recursion formula. They give you not only a sub 1, but they give you a sub 2. So we know we're starting with 4, 6. And what we need is a sub 3. And what the rule says is that a sub 3 is going to be a sub 2 plus a sub 1. So your next term is the sum of the 2 previous terms. It would be 10. And then a sub 4 is going to be a sub 3 plus a sub 2. It's the sum of the 2 previous terms, 16. Your next term is the sum of the 2 previous terms, 26. Your next term is the sum of the 2 previous terms. What is that? 42, right? And so on and so forth. So here they give you the first two terms, and the rule is a function of a sub n minus 1 and a sub n minus 2. It's simply the sum of those two. But that's another type of recursion rule they could give you, where you have two terms you have to work with. And believe me, when we come down here, these are going to be the tough problems. Finding the recursion formula for the sequence. And I tell you what, they're almost going to be impossible unless you're told that it has two terms you're working with. This last one, we're going to work with a sub 1 and a sub 2 and try to figure out the rule. These other ones, you're just working with a sub n minus 1. So we have a little better shot at getting it. Okay, so again, let's start with this sequence and find the term generator. Look at this sequence. What type of sequence is it? What is that?
Arithmetic.
Arithmetic with what difference?
-6.
-6. So what do we know? A sub 1 is 19. A sub n is a sub n minus 1 plus the difference, -6. So that's an easy one. Okay, that was arithmetic. Let's look at this one. What type of sequence is this one? Do you see it?
Symmetric.
It's geometric with what ratio?
-1/2.
-1/2. And so our a sub 1 is 4. Our a sub n is -1/2 times our a sub n minus 1. That's what a geometric recursion formula looks like. So I gave you two easy ones. Now, this is not arithmetic or geometric. And it is a function of just a sub n minus 1. But I'll give you a hint. It's one of those like the ones we did up top, where you had an n involved. Can anyone see the rule here? A sub 1 is 4. What is a sub n?
Is it a sub 1 times n?
A sub 1 times n, no, you mean a sub n minus 1 is what you want to say. It's n times a sub n minus 1. Your a sub 2 would be 2 times your a sub 1. And so you're getting 2 times 4 is 8. Your a sub 3 would be 3 times your a sub 2. 3 times a sub 2 gives you 24. Your a sub 4 is 4 times your a sub 3. 4 times 24 is 96. The next one is 5 times. So that's excellent. Your a sub n is n times a sub n minus 1. So you can see where these sequences are tough to figure out a rule like this. If it's not arithmetic or geometric, then they're tough. You have to just hope you see something. But we had one similar up here that maybe some of you recognize. And that's what made you think of it. And let's look at this last one. Now, this one I'm telling you is going to be given the first two terms. So we start with a sub 1 is 1 and a sub 2 is 1. Then we need to know what a sub n is. Does anybody see the rule? What is a sub n? Where are you getting 2 from? Where are you getting 3 from? Looking at the 2 previous terms. Where are you getting 5 from? What's happening?
Is it a sub n minus 1 plus a sub n minus 2?
There it is. You're getting this term by adding the 2 previous terms. That's why this is a 2 for this. It's 2 plus 1 is 3. 2 plus 3 is 5. 3 plus 5 is 8. So the next term is the sum of the 2 previous terms. So it's a sub n minus 1 plus a sub n minus 2. Okay, boys, that'll do it. A little different, huh? Just something to give you the edge. Just a different way to do a term generator. Instead of explicitly, you're doing it recursively. So that's kind of nice.